Okay, so it's about functions. Add, subtract, multiply, and divide them. So let's first of all talk about functions. Here is x squared. And you kind of know what it looks like. Over 1 up 1, over 2 up 4. Looks kind of like that, right? Remember square root 1? Square root 1 looks like this. And then you can slide it all which way to make that one right? Left 5. So I'm going to take these and slide them over to... Oops, somehow I have a marker missing. And I'm going to undo that. Grab and move them to left 5. 1, 2, 3, 4, 5. There. Now if I take this function, which I can just kind of rough out like that, and this function that generally goes like that, let's talk about their domains for a minute. The domain is what's really important. It has a domain and a range, but we're talking a lot about the domains today. Do you get that this one's domain is not limited at all? I can go forever this way and forever that way. Do you get that this one here's domain starts here and goes forever that way? Okay, so the domain on this one, you could say all real numbers. The domain on this one, you could say all real numbers where x has to be bigger than or equal to 5. Notice I said equal to 5. That's all it would take to get the problem wrong, is if you said just greater than. You gotta say greater than or equal to, because it can be negative 5. All right. What happens when I put these two functions together? Do you have any idea? I mean, is it going to look more like a parabola, or is it going to look more like a square root, or is it going to be some weird Frankenstein of the two? Well, let's find out. Grab your graphing calculator. Take the one function, x squared, and then add the other function, x squared plus square root of x plus 5. All right, here's mine. If you zoom out, you'll be able to see it better, because if you have the normal zoom, if you do like a zoom 6, I'll just do that so you can see what I mean. If you do zoom 6, it just looks like a parabola that's moved up a little bit. But if you zoom out, what it was, zoom out, number 3, and then they actually have to hit enter to make it actually zoom out. Can you see that part of my parabola got canned? So think about why that would be. Why can't I have anything over there? I'm going to go back to my functions here. See, I got the two functions that are put next to each other. Do you get why when I get over to like negative 6 that it doesn't work? Do you see it right here? As soon as I put in a negative 6 there, do you see how the whole function is going to crash? Because I have a square root of a negative in it. So the point is, this is the product, or not, actually the sum, of two functions. And if you think about it, it's like you are a child of your two parents. Your biological mother and father gave you a lot of traits that you're going to have to deal with later in life. Like, for instance, my dad had heart issues. Not terrible, not as bad as my... I've got a relative whose dad had really bad heart issues, had 14 years in a row he went in for operations on his heart. Okay, so he knows his heart's going to have issues. Well, he went in and they saw something a little funny on a stress test, and so they had to go in and check things out. They had to put in 7 stents in my it's my stepbrother's heart to keep him going. So why? Because he knew he was going to have trouble because his dad had trouble. And when they were asking me about it, and I started to think about it, it's like, okay, so let me think about my situation. My dad, we had, my half-brother and I have different dads. So anyway, my dad had some heart issues, but not real bad. But then I go to my mom, and my mom, her whole family had heart issues too. So it's like, oh crap, I got it on my dad's side and my mom's side, so I really are going to have a weakness there. See what I mean? So I have to be careful with my heart. My heart probably not going to, like, not till you're older usually, but probably be fine until I hit like 55 or something. But then I'm going to probably have to be really careful with, you know, like getting it checked and stuff to make sure there aren't issues, that blockages or whatever. Okay, so what's my point? My point is that these functions here are like the two parents. And do you see this one had no restrictions at all? It's like it's totally healthy. Get what I'm saying? And this one over here has got an issue. Like over here, it's got a weakness over there. It can't be over there. So then what happened to the child? The child that resulted when we graph it, it's got a weakness there too. See what I mean? It can't go over there. All right, so when you're doing functions, what you do to figure out the domain of a combined function, this function plus that function, or this one minus that one, or this one times that one, is you go back and look at the parents. Just like a doctor would do when they're checking over you. If you're younger, you probably haven't had any health issues yet, but what will they do? They'll ask you about your parents. And they'll know from looking at your parents what your future issues might be when you're older too, and what are you going to probably have. And some things, by the way, don't be too scared. Not everything transfers generation to generation. Some things do. Some things are very hereditary. Other things are just kind of random. You know, somebody gets certain disease. I don't want to name any, but if you get a certain disease, it could be not hereditary at all. Like, you just luck of the draw whether you're going to get that disease or not. And there's others that just definitely carry down in family. So back to ours, we check the two parents to see what the domain of the combined would be. So a typical problem would look something like this. Here's a function. Here's another function. And I'm going to take these functions and I'm going to add them. So I'm going to take this one and add them together to do this f of x plus g of x. Then I will subtract them to get a different function. Then I'll multiply them. I'll get even a different function. And then I can even divide them. And I get a third kind of function. So it's the first thing they ask you to do is actually add the function, subtract them, multiply and divide them. And then the hard part is the domains and the ranges of them. So if I was going to add this one and this one, it's as simple as you'd think. You just take x squared plus square root of x plus 5. That's it. Since I can't actually add that any further, then I'm done. That's all I got to do. You just add them, you just put them next to each other with a plus sign. Okay, how about subtract? Well, in this case, I can't actually make these guys go together. X squared minus square root of x plus 5. I have to leave it like that. I can't simplify it anymore. That's it. I just put them with a subtract sign. To multiply them, again, I really can't do much besides put them next to each other with a multiply sign. And then the last one is dividing. So at the top is x squared divided by the bottom one is square root of x plus 5. All right, so that's how you just add functions, subtract functions, multiply functions. It's really easy. That you just put them together. Now sometimes they're more complicated because like they might be x squared plus 2x for this function. And this other one over here might be negative x squared minus 2x plus 4. So I could have these two functions, and what happens when I add them? Well, you can actually make something happen when you add them. X squared plus 2x plus negative x squared minus 2x plus 4. I'm adding this and that. Do you get that there's some parts that can go together? So if you can combine things, you should. So like this and this can go together, and they're going to cancel and be gone. And that are going to go together, and they're going to cancel, and they're going to be gone. And the only thing left is the 4 here. So when I add these two functions, my function is just f of x equals 4. That's it, because everything else cancels. So if you can put things together, you should. Really common mistake people make is on the subtracting one. If I'm going to subtract these two functions, I want you to give it a shot. Tell me what you think f of x minus g of x is, and I'm going to see how many of you fall into the trap. Okay, give it a shot. On paper right now. So what'd you get? So when you subtracted them, somehow you ended up putting two things together and adding them? How would that happen? Well, let's see. X squared plus 2x, and then you subtracted all of this, negative x squared minus 2x plus 4. And this negative gets distributed with that negative and makes it a plus, so you are absolutely right. 2x squared. Okay, and then this negative goes with this negative, makes that positive, and a 2x and another 2x makes plus 4x. And this negative goes with this, makes it minus 4. Who of you caught that and did it right? Awesome. It's more than half the class. All right, I bet a lot of you goofed up with the negative. Be careful. Put a minus, put a parenthesis, drop the whole function in, and then you got to remember to distribute that negative to each part. Okay. Now, what's the hard part on this? That's all been very easy. It's the domain and range part. Okay, everybody, write this problem out again. This is domain and range. You won't be able to put it over the top of the old one because there's not going to be enough room. So how do I do these kinds of problems? The first step in every problem you do, I want you to write the domain underneath the function. Get used to doing that for this whole unit. Okay? Underneath this one, we want to say, what's the domain of f? We call it d sub f. The domain of f is, well, just think about it. That's a parabola, right? Goes forever both directions, right? Left and right, so it's all reals. No restrictions. No. And what's the domain of g? This one is restricted. It has to stay, what's underneath the root, you set that greater than or equal to 0. Yep. X plus, that's supposed to be a 5. It has to be greater than or equal to 0. So then I could solve that and say x has to be greater than or equal to negative 5. See what I just did there? Took what's underneath the root and I set it greater than or equal to 0. And then I solved it. Okay. So my domain is, it has to be negative 5 or bigger than that. That makes sense to you? If I put in a negative 5, it's okay. And if it's smaller than that, it wouldn't be okay? All right. So now, here's my domain of this one. Here's my domain of that one. Now, if I wanted to find the domain of this guy, I'm not even asking you to figure out what is f of x plus g of x. It's just what is the domain of f of x plus g of x. You look back at the parents. It's like this guy has come in for his doctor's appointment. There's nothing wrong with him right now, but he wants to know, like, what's my future going to be like. By the way, did you know that I saw a series called $1,000 Genome the other day, where they're going to be able to sequence your genes. It's already down to probably $2,000 or $3,000 cost to sequence your genes for you. And what this does is it can give you a printout and tell you, here is your genome, all of your, basically like your DNA. And here's everything we know about what's probably going to happen to you. Like, you're probably going to get cancer when you're 50. You might go blind from diabetes at 65. I mean, it is a little creepy. So there's a lot of ethics kind of questions about this now. But can you imagine a lot of people going to the doctor and saying, yeah, go ahead and run it, I'll pay the $1,000, I'd like to know. See what I mean? And there's other people that would say, I don't want to know. I don't want to know what I'm going to get. I'd rather just live my life and then just let it happen. It's a lot like what people do with babies. Do you know people who have said, I don't want to know what the baby is? I just want to be surprised. And there's other people who definitely tell me, because I want to plan. I want to buy clothes. I want to paint the nursery and all that stuff. So anyway, that's just an interesting topic I thought was kind of related. It's a series on public TV called $1,000 Genome, because the price is getting soon going to be at that magic number of about $1,000, which you figure a lot of people will be willing to pay to know what the genome tells about their future. And by the way, it's not as accurate as at age 52 you will get cancer, but it does say things like you have a strong predisposition to, as in you're very likely to get cancer. And then that sort of at least gives you hope that you might, through eating healthy or whatever, be able to avoid it if you know it's coming. You know what I mean? Or that there's a chance of it coming. Okay, so back to this. How do we get our domain for these? You just take this one and you overlap them. So what do I mean by that? Well, this one's domain is all real numbers, so everything works on the one on the left. The one on the right, I'm going to make a number line for that separately, and I make my -5 somewhere. It doesn't really matter where on it, like this. And can it be -5? Yes. Fill it in. And then I'm going to shade to the right, so that's what that one looks like. All I did is graph that right there. And do you get that they overlap in two spots, or in one spot? From here over, they overlap. So wherever they overlap, that's the answer. So you graph the one, you graph the other, you see where they overlap. And the good part is, it's the same answer for all three of these. The add, subtract, or multiply functions all act the same way. You just look at the two parent things and see where they overlap. So the answer for all three of these is the domain is all real numbers except x has to be greater than or equal to -5. Now, some people say that you just pick the more restrictive domain. Do you get that this is more restrictive than this one is? And that works for this kind of a problem. But sometimes you're going to get answers that look like this. It works from here to here, and there to there, and you're overlapping it with something that works like from here to here, and an empty spot there, and then works again from here to there. Now I'm going to put some numbers on this. Say this is -2, this is negative, no, that wouldn't make sense. -1 right there. Let's say this is 0. Let's say that's at 1 and that's at 2. Do you get the, if you just look at these, can you see that they overlap in a couple spots? But if I said what's the more restrictive domain, it wouldn't always tell the whole story. Especially if there's, like if I threw in one more thing, let's say I made it work all the way through here. Okay, and I'll leave this as an empty spot right there. So, if I'm now going to tell what's the, well, where do they overlap? Where is the, and this was supposed to be working down here. Where do they overlap? They overlap from there to infinity. And I'm being distracted by the hallway. I'm going to pause this a second. All right, so this is where this thing overlaps. So I would say it was from negative infinity up to -2, and it worked at -2. Union with, the next spot it overlaps starts over here. And it overlaps from 2, and it works at 2 to infinity. There's my domain of those two number lines. All right, I'm going to give you a couple number lines, and I want you to tell me what you think the domain would be. Let's say I graph this one, and it ends up being like this. 5 goes that, and here, down here. Actually, let's make it work everywhere except 5. And then, say it goes, this one goes from 3 to 7, it works. Tell me what the overlap is. Those are the two parent domains. What would be the domain of the resulting function? Do you get the overlap in here? Except not at the phone. And then do you get the overlap in there? So I hope you said from 3 to 5, and it works at 3, and it doesn't work at 5. Union with, starts working again after 5, and goes to not infinity, to what? Does it work at 7? See how that uses a lot of your skills with the parentheses and the brackets and everything? So that's a restricted domain. No, that's a domain of a combined function. All right, so there's one more kind, and that's where you take f of x and g of x, just like we had before. Let's see these guys. And we haven't done this divide yet. All right, what if you divide the two functions? It is as simple as you just put f of x on top, and you put g of x on the bottom. That's how you actually make the function. You just divide. You put the one over the other, and that's it. It's not hard. But if you have to find their domain, you have to do 3 number lines. What on earth? you have to do 3 number lines. First number line is the f of x number line. Okay, that's all real numbers. So it's like this. Everything works. The next number line is the g of x number line. You know, because there's that in the function too. So we look at that, and that one is x is greater than or equal to negative 5. So I'm going to make one for that. Here's negative 5, greater than or equal to negative 5. The third number line you need to put in there is, do you get that unlike all the other ones up here, this one has a denominator? What's special about denominators and domains? They can't be 0. So do you get that I have to figure out when g of x would ever be 0 and that would be a problem for me? That's my third number line, is when would g of x be 0? I'm going to make a third number line for that. When would g of x be 0? Here's g of x. When would it be 0? It's not normally a problem for it to be 0, because you can be 0 if it's not the denominator. But in this case, it's a denominator, so if I make that negative 5 right there, I put a negative 5 in there, it's going to crash my function. So isn't it true that the only thing I'd have a problem with, as far as the fact that it's a denominator, is that it can't be negative 5? That's the third thing. Okay, so some of you, like, my brain just exploded. All we did was add in one more factor, and that's that you set g of x equal to 0, and you see what would cause it to crash if this was equal to 0. And you put that in as an empty spot on a number line. And now I got to see where all 3 of them overlap. So now it was overlapping from here to forever. But now if I factor in this third thing, it can't be negative 5. So this one's domain, this combined function right here, because it's got a divide, it has this third line in it. It would be x, or all reals, where x has to be greater than negative 5. I know it's a very subtle difference. This is as an or equal to, and this one doesn't, but that's all it takes to be different. And a lot of kids will not think of that on the test, because they'll remember, oh, you graph the 2 number lines, see where they overlap. But they'll forget about on the divide one that you got to throw in that extra third number line and factor in that the denominator can't be 0. All right, so there's one of the secrets to getting this one right. That is a cell phone that needs to go on my desk. Please don't do it. All right, so the last thing, actually, I don't even have to teach you the last thing today. We can wait for that till tomorrow, and that's good. So that's all you need to know. I'm going to start your worksheet with you, and then we'll hand back the tests after that. The tests you took before you left. Remember? Oh, you do your class already? Get them back? Were all you guys here? Who was not here that day when I handed the test back? Okay, then I guess I'll just hand it back to you guys. All right, so anybody that doesn't need it, just remind me. You need one of these, even though you probably want to watch the video. Understand? Please remove your lid. Okay. All right. Here we go. Let's do the first problem off the worksheet, which says, number 1, f of x is 2x minus 1, and g of x is x squared. Well, what do I actually do? Look in the directions. For each problem, find f plus g and its domain, f minus g and its domain, and f times g and its domain. So here's what you do. First thing you do underneath each one is tell what the domain is. Really small because we don't have much room to write here. But d of f. d sub f is the domain of the f function. And what is it, by the way? Is there any restrictions on it? All real numbers except nothing. All real numbers. There's no restriction. And what's the domain of G? Really small underneath the G function, you write that. Is there any restrictions on that thing? No, think about the picture of it. It's just a parabola. It goes forever to the left, forever to the right. So it's all reals also. Can you picture the number lines for them? They're just like all filled in completely. And if you're going to overlap them, they're going to totally overlap all the time with all real numbers. Okay, so anyway, now we got to do each little part. It wants f plus g. So off to the side, you say f plus g. And we figure out what that is. That's this plus this. So yes, I could just write them in the order I see them, but I know the x squared has to be arranged to be first. So I'm going to put x squared plus 2x minus 1. That's just them added. I just put the x squared first because you're supposed to. Otherwise, it wouldn't be written in the right order. You know what I mean? Like if I put the plus x squared, it'd be okay. It's just not written in the right order. So it's smarter to do it this way. Okay? And then what's the domain of that? Well, you overlap the two number lines. Do I really need you to draw number lines if they're both all real numbers? No. But they would just be two number lines that are totally overlapping each other all the time, and you'd say all reals. Notice that they haven't got us dividing at all yet. Okay? They haven't got us doing f divided by g. That's the tricky one. I already explained it to you, but that's one of the main things I got to teach you tomorrow. Okay, so that's f plus g, then let's do f minus g. It's just 2x minus 1 minus the g function. There we go. Except I should really put that x squared first. Is that important? Yep. And I'll move it to the front. So negative x squared. Hey, I just touched that thing wrong and it pulled up a whole different document. Okay. Just move this over. And I'm going to put that minus x squared in the front. Okay, and then the last one is f times g, or fg. And that just means multiply them together. Now here's where some people forget the parentheses around 2x minus 1 times x squared. Could you put the x squared first? Yes, you could. I'm not going to make the rearrange it. You can't just slap the x squared on this. Well, you have to put it on both of them if you want to distribute it up. All right, so there we go. And all of these have the same exact domain. Once you figured it out, it's just the same thing. All reals, all reals. All right. Now this worksheet has painfully small amount of room to work. On the back side, you have more room. Or B, if you have a piece of lined notebook paper you want to do it on, I know it's not much room. If you want to go off to the side and do it on notebook paper, that's fine. You only have to do problems 1 through 8 today. And that will get you through some of the ones where you're going to actually divide them. And then remember, the ones where you divide are the kind you have to do 3 number lines, and where all 3 number lines overlap. That's for 5, 6, 7, and 8 will be like that. Okay, so it's 1 through 8 for today. Don't like scribble out the rest.